Hello students, welcome to AIMS in the online classes. This is a chemistry session. Here we are discussing about chemical bonding chapter. In the earlier sessions we have seen different kinds of chemical bonds like ionic bond formation and covalent bond formation, how these are formed we have seen. Now we are going to see a special kind of covalent bond which is known as coordinate covalent bond or dative bond. Okay, let us see about this in this session. A covalent bond, in general, a covalent bond is formed by two atoms sharing a pair of electrons. Isn't it? We have learned in the previous sessions that a covalent bond is formed between two atoms when both the atoms contribute one electron for sharing, and that pair of electrons are shared by both the atoms. Then a covalent bond is formed. The atoms are held together because of the electron pair is attracted by both the nuclei, isn't it? Generally, in the formation of a simple covalent bond, each atom supplies one electron to the bond formation, and these pair of electrons are shared by both the atoms. But in some special type of covalent bonds, the shared pair of electrons are contributed by only one atom, and that pair of electrons are shared by both the atoms. Such kind of covalent bonds, in which the shared pair of electrons are contributed by one atom and shared by both the atoms, are called as coordinate covalent bonds or dative bonds. Okay, let us see the definition for it. Coordinate covalent bond. The covalent bond in which both electrons of shared pair are contributed by one of the two atoms and shared by both the atoms is called coordinate covalent bond. This coordinate covalent bond is also called as a dative bond. A coordinate or dative bond is established between two such atoms, one of which has a complete octet and possesses at least one lone pair of electrons, while the other is short of a pair of electrons, means which is ready to accept a pair of electrons. So to get octet, when these two kinds of atoms approach each other, then they form a dative bond. Representation of the coordinate covalent bond. So how to represent a coordinate covalent bond? We have studied how to represent a covalent bond. Just by drawing a simple line between the symbols of two atoms, we can represent the covalent bond formation between those two atoms. But how to represent a coordinate covalent bond which is different from that? In simple diagrams, a coordinate covalent bond is shown by an arrow mark, which is shown here. See, by this arrow mark, a coordinate covalent bond is represented. The arrow points from the atom donating the pair of electrons to the atom which is accepting that pair of electrons. Okay. For example, if you see the bond formation between these two atoms A and B, here if you observe A, it has 8 electrons in its octet, or it is having 8 electrons in its valence shell. That means it is already having octet and has lone pairs of electrons in its valence shell. See, 4 pairs are there. And if you observe this B, atom B, it has 6 electrons. That means 3 pairs of electrons are there. It is still need of one more pair of electrons, 2 more electrons to become stable with octet configuration. Now, when these two atoms approach each other, here A donating its pair of electrons for sharing. Remember, donating in the sense it is not giving completely to B. It is donating its pair for sharing with B. So it is donating its pair of electrons, and this pair of electrons are shared between these two atoms. Thus, a covalent bond is formed which is called as coordinate covalent bond. By that, A is not getting any extra electrons because it is donating its pair of electrons only. And B, it is sharing these two electrons of A, and hence it is also getting octet. Okay, thus the bond formed between these two is called coordinate covalent bond, and it is represented with this arrow mark. Okay, here it is pointed from the atom which is donating this pair of electrons to the atom which is accepting that pair of electrons. The atom which contributes electron pair is called donor, and the atom which is accepting that pair of electrons is called acceptor. See, in the formation of this molecule AB, A is donating its pair of electrons, so it is called donor. So the atom or molecule which is donating its pair of electrons for the formation of dative bond is called donor, and the atom which is accepting that pair of electrons is called acceptor. So here B is called acceptor. Okay, we have to note one more point here. Coordinate covalent bond is different from covalent bond just before the bond formation, because in the covalent bond formation both the atoms contribute one electron from each, and that pair of electrons are shared by both the atoms. But in the formation of dative bond, both the paired electrons are contributed by one atom and shared by both the atoms. So that is the difference between the covalent bond and coordinate covalent bond. But once after the bond formation, this coordinate covalent bond is completely indistinguishable from covalent bond. Means both will be similar. After the bond formation, covalent bond and coordinate covalent bond both are similar. Okay. Now let us see some examples for the molecules having this dative bond or coordinate covalent bond. First let us see the formation of ammonia boron trifluoride molecule, NH3BF3 molecule. We know in the ammonia molecule, although the nitrogen atom has completed its octet in ammonia, it still has a lone pair of electrons in its valence shell which can be donated. Isn't it? We know nitrogen has 5 valence electrons. Out of these 5 electrons, 1 electron is shared with each hydrogen atom. So 3 electrons are shared here. Thus, nitrogen is getting octet configuration. And then it is having one lone pair of electrons in its valence shell. At the same time, if it is in boron trifluoride molecule, in that boron atom is short of 2 electrons even after the bond formation with the 3 fluorine atoms, because fluorine has 3 valence electrons. These 3 valence electrons are participating in the bond formation with the 3 fluorines, and hence fluorine is getting 6 electrons. It is still need of 2 more electrons for getting that octet configuration. So it is ready to donate one pair of electrons. It is ready to accept a pair of electrons. Now when these two combine, they form a coordinate covalent bond between nitrogen and boron, and thus they become stable. Okay, here the molecule or atom which is donating this pair of electrons is called donor. Okay, and at the same time the molecule or ion or atom which is accepting that pair of electrons is called acceptor. Ammonia is donor, boron trifluoride is acceptor in this molecule. Ammonia boron trifluoride is formed in that way by the formation of a dative bond. Okay, here any atom or ion or molecule which has one unshared electron pair which it can donate is termed as Lewis base, while those which are capable of accepting that lone pair of electrons are termed as Lewis acids. So to say simply, in the dative bond formation, the atom or molecule or ion which is donating pair of electrons is known as Lewis base, while the atom or molecule or ion which is accepting that pair of electrons in the formation of dative bond is called Lewis acid. Okay, in the previous example, that is in the formation of ammonia boron trifluoride molecule, ammonia donating pair of electrons, so ammonia is said to be Lewis base, while boron trifluoride accepting that pair of electrons from ammonia, so ammonia boron trifluoride is said to be Lewis acid. Okay, the acceptor is called acid, donor is called ammonia in the dative bond formation. Sorry, donor is called Lewis base in the formation of dative bond. Let us see another example for the molecules having coordinate covalent bond. That is, let us see the formation of ammonium ion, it is formed between ammonia and hydrogen ion. In this, hydrogen ion has no electrons and thus it is ready to accept a pair of electrons which can be donated by other molecules. And we have seen just now in the previous example also about ammonia. Ammonia is ready to donate a pair of electrons because it is having one lone pair of electrons and it is with a complete octet. Now when these two combine, ammonia and hydrogen ion, a coordinate covalent bond is formed between ammonia and H plus ion. In this, ammonia, which is donating a pair of electrons, is said to be Lewis base. And the H plus ion, this is the H plus ion, which is accepting that pair of electrons, is said to be Lewis acid. Acceptor is acid, donor is base. Okay. Let us see one more example, that is formation of ozone molecule. We know the molecular formula of ozone as O3. Ozone molecule consists of three oxygen atoms. Out of these, two oxygen atoms linked by a double covalent bond. So when three atoms are clubbed, first two oxygen atoms will be joined together by formation of a double covalent bond or double bond. Now, each oxygen atom has two lone pairs of electrons. See here, in this, first these two oxygen atoms are combined by sharing two pairs of electrons between them. By sharing of two pairs of electrons, each oxygen atom is getting octet because each oxygen atom initially they have 6 electrons in their valence shell. This has 6. By sharing these two electrons, it is getting octet configuration, isn't it? At the same time, if you see this oxygen, already 6 electrons are there, it is sharing 2 more electrons from that oxygen and hence it is also getting octet. Now, one of these two oxygen atoms which are having two lone pairs of electrons each, they donate one of the lone pairs to the third oxygen atom. Say this oxygen atom, it is donating its pair of electrons to this and thus to share this pair of electrons. By that, it also gets octet. Observe, it is not getting any extra electrons by sharing this pair with it. It is still maintained with octet configuration. Thus, three atoms becomes stable. Okay. So one more point you have to note here, that is the H plus ion and the cations of transition metals such as copper, cobalt, iron, manganese, chromium, nickel, etc. The ions of these metals act as Lewis acids. What does it mean by Lewis acids? We told the atoms or ions or molecules which are ready to accept a pair of electrons in the formation of dative bond are called Lewis acids. So if you observe, these all are ready to accept a pair of electrons and thus these all are called Lewis acids. And the donors of this lone pair of electrons are called Lewis bases, which are also called as ligands. The atoms or ions which are ready to donate a pair of electrons in the dative bond formation are called ligands. Okay. Now let us see the characteristics of these coordinate covalent compounds. The melting and boiling points of these coordinate covalent compounds are higher than that of purely covalent compounds and lower than that of ionic compounds. Okay, they are being in between the properties of ionic compounds and covalent compounds. These are sparingly soluble in polar solvents like water. What is meant by here polar solvent? We know water is a polar solvent. That means water is a polar compound. We have seen in earlier sessions what is meant by polar covalent bond. The covalent bond which is formed between two different atoms or the atoms with the two different electronegativities is called polar covalent bond and that molecule is called polar compound. And if it is a solvent, it is called polar solvent. We know water is a polar compound and it acts as a solvent, hence it is called polar solvent. These coordinate compounds are being non-polar in nature. They are not soluble or sparingly soluble. Sparingly soluble means they are less soluble in water. Water and polar solvents like water. But they are readily soluble in non-polar solvents. Non-polar solvents means the compounds which are having non-polar covalent bonds. Means where the shared pair of electrons are shared equally between the two atoms. So such kind of solvents are called non-polar solvents. These coordinate compounds are fairly soluble into non-polar solvents. Next, like covalent compounds, these ordinate covalent compounds are also bad conductors of electricity. Their solutions or fused masses, they do not allow the passage of electricity through them, because just like the covalent compounds, these coordinate covalent compounds also, they do not have any formation of ions in them in the solvent form or in the fused form. They do not form any ions. That's why the compounds, coordinate covalent compounds, are bad conductors of electricity. They cannot pass electricity through them because there is no formation of any ions in the aqueous form or in the fused form. And the bond is rigid and directional. So just like the covalent bond, coordinate covalent bond is also directional because it is also formed, it is localized between two atoms. Hence, it is said to be directional bond. Covalent bond and coordinate covalent bond both are directional. Whereas we have studied ionic bonds are non-directional because there each ion will be surrounded by number of oppositely charged ions from all the directions. So there is no one fixed direction for the attraction. The attraction will be there from all the directions. That is why ionic bond is said to be non-directional, whereas covalent bond and coordinate covalent bond are directional because they are said to be localized between the atoms. Next, let us see another kind of chemical bonding that is called the metallic bond. The bonding and structures adapted by metals and alloys are less understood with ionic and covalent compounds. Any successful theory of metallic bonding must explain both bonding between a large number of identical atoms in a pure metal and the bonding between widely different metal atoms in alloys. So the bonding between the metal atoms of same kind of atoms or different metals. These are not explained properly in the ionic compounds and covalent compounds explanation. So a separate explanation is needed for explaining the bond formed between the metal atoms in the alloys as well as pure metals. So suppose this is a metal crystal. There, each metal will be having certain valence electrons. So the attraction between these electrons and the positively charged metal ions is said to be actually metallic bond. So these valence electrons of metals, they won't be fixed at one position. They'll be moving continuously from in the valence cloud of all the atoms. So it is delocalized. So between the delocalized electrons and the metallic ions, there occurs certain attraction. That attraction is said to be the metallic bond. Let us try to define this. A bond that holds metal atoms together on account of force of attraction between the metal ions and the free electrons in the outer shells of these metals are called is called metallic bond. So each metal atom is having certain number of free electrons in their valence shells. So the attraction between these metal ions and the free electrons of these metal atoms in their valence shells is said to be metallic bond. In a metal, in a metal crystal, each atom is surrounded by around 8 to 12 other metal atoms. The metallic bond is non-directional in nature because here also, just like the ionic compounds, each metal atom is surrounded by number of valence electrons from all the directions. So the attraction between the valence electrons and metal atom occurs from all the directions. Hence it is said to be non-directional, whereas covalent and coordinate compounds are directional bonds. Okay, metallic and ionic bonds are non-directional in nature. And it is just a attraction between the metallic ions and valence electrons of these free metal ions. As it is just attraction between them, it is weaker than covalent and ionic bonds. Okay, that's about metallic bond and coordinate covalent bond. Thank you for watching our video. Please subscribe our YouTube channel Aims Today for latest updates and recorded videos. And please visit our website aimstoday.in for other information regarding online classes, quizzes, live worksheets, do-it-yourself activities, English classes, coding, reasoning, and more.